Using 3 space telescopes, Armenian astronomers have observed a flaring high redshift blazar known as PKS 537286. Results of the observational campaign, presented February 15 on the preprint server arXiv, deliver important insights into the properties and origin of the multiwavelength emission from this source. Blazars, classified as members of a larger group of active galaxies that host active galactic nuclei (AGN), are the most numerous extragalactic gamma-ray sources. Their characteristic features are relativistic jets pointed almost exactly toward the Earth. Based on their optical emission properties, astronomers divide blazars into 2 classes: flat-spectrum radio quasars (FSRQs) that feature prominent and broad optical emission lines, and BL Lacertae objects (BL LACs) which do not. At a redshift of 3.1 and with an estimated luminosity at a level of 1 quattrodecillion erg/s in the 0.1-2.0 kilo-electron-volts range, PKS 537286 is one of the brightest high redshift blazars, classified as an FSRQ. The source exhibits gamma-ray flares, which makes it the most distant gamma-ray flaring blazar so far detected. A team of astronomers led by Narek Sahakyan of the International Center for Relativistic Astrophysics Network (ICRANET) conducted optical, ultraviolet, X-ray and gamma-ray observations of PKS 537286 in order to shed more light on the emission from this blazar. For this purpose they used NASA's Fermi, NuSTAR and Swift space telescopes. We present a multi-frequency spectral and temporal study of high redshift blazar PKS 537286 by analyzing data from Fermi LUT, NuSTAR Swift XRT and UVOT, the researchers wrote in their paper. The team analyzed the data collected during a time span of 14 years between 2008 and 2022. It was found that the gamma-ray emission from PKS 537286 appeared to be relatively constant until 2017, when multiple powerful gamma-ray flares were identified. Afterward, the blazar was in an enhanced gamma-ray emission state when the gamma-ray luminosity reached 61.4 quindecillion erg/s. During the whole observational campaign, the gamma-ray luminosity of the source exceeded 1 quindecillion erg/s for nearly 62 days in total. Furthermore, the study found that the gamma-ray photon index of PKS 537286 also showcases variability over the observed period. The mean value of the gamma-ray photon index during non-flaring periods was measured to be approximately 2.83, which substantially hardens during the flares. It appears to be a moderate anti-correlation between the gamma-ray photon index and blazar's luminosity. According to the observations, PKS 537286 is very luminous also in the X-ray band with a 0.3-10 keV luminosity between 0.1 and 1.0 quindecillion erg/s. The X-ray emission of this blazar is characterized by a hard spectrum of below 1.38. The astronomers concluded that the flares of PKS 537286 are most likely due to the hardening of the emitting electron spectral index and shifting of the cutoff energy to higher values. The modeling in the quiescent to flaring states showed that the flare was caused by the electron distribution changes, i.e., the electron power law index hardened to P equals 2.2 plus or minus 0.1 and the cutoff energy was gamma cut equals 2.5 plus or minus 0.2 times 103, the authors of the paper explain.